Hey guys, this is Mr. Bennett. This is Unit 3, the atom, and this is video 3-2, talking about distinguishing between atoms. So I'd like to start off with a little bit of review of the atom. We talked about them yesterday, and what I'd like you to do right now is, if you assume that these red dots here are protons, and the blue dots are neutrons, I'd like you to determine what elements are shown here. So pause the video and see if you can figure it out. Alright, hopefully you pause the video, and what you should have seen is that there is one proton in each of the three atoms. Doesn't matter which one you're looking at, they all have one proton, and we know that the number of protons equals or determines the element. So if we were to look at that, it turns out on the periodic table, atomic number 1, or the number of protons, would be hydrogen. Okay, and I just mentioned something, pointed out, the number of protons is also defined as the atomic number. So the atomic number is equal to the number of protons. There's one, tells us it's hydrogen. So what's different about the three then? Well, it turns out it's the number of neutrons, right? So number of neutrons is different between the three. And something we talked about in our prior video was the mass number. Mass number is equal to the protons plus the neutrons. So if we were to look at these three, it turns out their mass number varies. The first one has a mass number of 1, the second one has a mass number of 2, and the third one has a mass number of 3. It's because there's one proton here, there's one proton and one neutron here, they each have a mass of 1, so 1 plus 1 equals 2. And then 2 neutrons plus 1 proton gives us a mass number of 3. So all that's different between the three hydrogens is that their mass is slightly different. This is what we call an isotope. Isotopes of the same element, okay, basically just have different numbers of neutrons. That's all an isotope is. They're atoms of the same element, but with different numbers of neutrons. Think of them as being heavier or lighter versions of the same element in terms of mass. Okay, so isotopes of the same element behave like the element. Chemically, they're the same. Okay, tin has 10 different isotopes, but they all act like tin. The only difference you may run into is that some are going to be unstable. Those extra or fewer numbers of neutrons could make them unstable and essentially make them radioactive. The mass numbers are different, that's all. Okay, what is the same is the atomic number. So the atomic number must be the same. If it's not the same, then it's not the same element. Okay. So, give you an example here. Carbon exists in 3 different isotopes, carbon-12, carbon-13, and carbon-14. Determine the number of protons, neutrons, and electrons for each. So let's take carbon-12 for instance. Okay? If we look up carbon on the periodic table, it has an atomic number of 6. Okay? Turns out that the atomic number tells us the number of protons. So, if it has an atomic number of 6, that means we have 6 protons. Alright? Now, neutron-wise, we know that the mass number is equal to the protons plus the neutrons. And it also turns out that the mass number is right here. Okay, that's what it means when we put this number after the element's name. This is the mass number. So it's telling us the combination of its protons plus its neutrons. Well, we know that it has 6 protons. It has to have 6 protons to be carbon. Okay, if it were 7, this would be nitrogen, it wouldn't be carbon. If it were 5, this would be boron. So it has to have 6. Okay, so if we take the mass number, which is protons plus neutrons, and we subtract the number of protons, we'll be left with the number of neutrons. So 12 minus 6 gives us 6. Okay, now for the last one, electrons, if we assume that these guys are neutral, okay, so we assume the atoms are neutral, then what that means is that protons have a positive charge and electrons have a negative charge. With 6 protons in the nucleus, that means 6 positive charges. For it to be neutral, we need 6 negative charges on the outside to balance it out. Alright, so what I'd like you to do is take a look at carbon 13 and 14. I'd like you to determine these numbers on your own, okay, and then come back and check how I did it. So pause the video and try it out. Okay, hopefully you paused it. What you should have seen is that carbon-13 and carbon-14 both have the same atomic number as carbon-12, otherwise they wouldn't be carbon. Neutron-wise, we take the mass, we subtract the number of protons. 13 minus 6 gives us 7 neutrons. Carbon-14, 14 minus 6 protons gives us 8 neutrons. The neutrons plus the protons give us this number. Okay, and then if we assume that the atoms are neutral, that means that we still have 6 protons in the nucleus, so we still need 6 electrons on the outside to balance it out. Okay, now when we identify isotopes of an element, isotopes of the same element will have the same atomic number but different mass numbers. Also realize that mass number is interchangeable with what we call the atomic mass. These terms mean the same thing. It's the mass of the atom or the mass number. Mass number is just protons plus neutrons. So if we look at element X here, just a generic element, notice the mass numbers, okay, which are right here and right here, they are slightly off. This one on the left has one more neutron. On the bottom, these numbers, these are the atomic numbers, and the atomic number is also known as the number of protons. Okay, notice they are the same, which means they are the same element. So what I would like you to do on your notes, you have a picture of this guy right here. I would like you to label 48 as the mass number and 22 as the atomic number. Okay, assuming you've done that, let's move on. Average atomic mass. Okay, average atomic mass is something special. Realize so far we've talked about atomic mass, we've talked about mass number, and we've talked about something called the atomic number. So 3 things that sound very simple, or similar rather. Now we're adding a 4th thing that sounds really similar, except it has this extra word at the front, average. Okay, the average atomic mass is found on the periodic table. Okay, the average mass, it is the average mass of an element's atoms as found in nature. It is not the atomic mass or the mass number. These guys are specific to an isotope or to a particular atom. Okay, the average atomic mass looks at the universe and says this is the average mass of this particular element. So it takes into account all isotopes and their abundance within the universe. So lithium-6, for instance, has an 8% abundance. Lithium-7 has a 92% abundance, which means most of the lithium around us in nature has an abundance of about 92%. So, and it's lithium-7. Okay, so if we were to calculate the average mass, we would find out that, again, that mass of 7 lithium is 92% abundant. Mass of 6 is 8% abundant. Put it together, the average lithium has a mass of 6.92. This is the number that you find on the periodic table. Okay, this is not the mass number. The mass number would either be a lithium-6 or a lithium-7, depending on which specific atom you're using. Okay, so let's talk about what's the difference between these guys. Again, they sound really similar, right? So atomic number, this guy here, is always the smallest number because it's the number of protons. Okay, the average atomic mass always has a decimal and it's on the periodic table. Why? Because it's abundance in nature. Okay, that's all it tells you. It's the abundance in nature. The mass number, on the other hand, also known as the atomic mass, is not on the table, and it is always a whole number because it's specific to an atom. Okay, you're talking about a specific atom here, whereas here you're talking about the average of that element in nature. So what I'd like you to do on your notes is looking at these 2 examples. This one's from the periodic table. This is what we call standard element notation. So if we were to look at a particular atom of an element, this is standard notation for it. Okay, what I'd like you to do is I'd like you to label, wow, that's horrible, there we go. I'd like you to label the atomic number, the atomic mass, and the average atomic mass. So if we're looking at the periodic table, this guy here, always the smallest number, this is the atomic number. Okay, right there and right there. This guy has a decimal, so that means this is the average atomic mass. And this guy is a whole number and it's the biggest one of the 2. Okay, that means that this is the mass number, also known as the atomic mass. No average here. Okay, it's not a decimal, etc. Okay, now we've got 3 practice problems. Here's the deal. I expect you to challenge yourself. That means I'm going to show you the problem. You need to pause the video, try to do the problems on your own, and then come back and see if you got them right. So go ahead right now, pause the video, and see what you can do. Okay, I'm hoping you pause the video. I even paused myself there for a second, staring at you. So here's the deal. Practice problem number 1. What is the identity of an element with an atomic number of 12 and a mass number of 26? Write out its symbol in standard element notation. Okay, few different ways you can do this. First of all, you need a periodic table for this, or you got to go online. You're online right now watching a video. You should be able to look up ptable.com or something like that. Okay, so atomic number of 12. What does that tell us? This guy right here. Well, that tells us the element. We can look up atomic number 12 on the periodic table, and that tells us we're looking at magnesium. Okay. Also, we always put the atomic number 12, or the atomic number, on the bottom. Standard element notation always has the mass number on top and the atomic number on bottom. So I've put my symbol here, my atomic number is on bottom, my mass number goes on top. So this is my answer. Okay, magnesium 26. Does the mass match the mass on the periodic table? Why or why not? First of all, no, it does not. Why? Because this is for a specific atom, right? The periodic table, on the other hand, is an average in nature. It's average of abundance in nature. Okay, so this will be a decimal because it's looking at all the atoms in nature and coming up with an average, whereas this will be a whole number because this is this particular atom and its particular mass. Okay, practice problem number 2. Which notations are isotopes of the same element? Okay, yes, I realize they all have X as their symbol, but that means that they're unknown. We don't know what element it is. So we need to look at these numbers over here and see what they tell us. Okay, as a reminder, the number on top, that's your mass number. That tells you how much mass this particular atom has. On the bottom, that's our atomic number, okay, also known as the number of protons. Mass number up here was protons plus neutrons. And the thing about the atomic number, the number of protons, is it determines the element. So what does that mean? Well, that means that in this particular scenario, that if they have the same atomic number, they are the same element. So if we look at this, we have a 13, a 12, a 12, and a 26. So we only have 126, it can't be the duplicate. We only have 113, it can't be the duplicate. Right here, they have the same atomic number, therefore they are both magnesium. They both have atomic number 12. We look to the periodic table, that's magnesium, same element. Last and final problem for the isotope sodium-23. Okay, let's answer these questions. First of all, if you go to the periodic table, symbol for sodium is Na. What does the number 23 represent? Okay, when we put this on the end like this is the mass number, okay, also known as the atomic mass. And if we really want to get crazy, we could even say that this represents the number of protons plus the number of neutrons. Craziness, right? What is the atomic number? Well, if we go to the periodic table and we look up sodium, turns out sodium is number 11. So atomic number equals 11. And if we really want to get crazy, we could even mention that this is the number of protons. So how many neutrons does this atom have? Well, I can take the atomic mass, which is the protons plus neutrons, and it's 23. I could then subtract the atomic number, which is the number of protons, 11, and I'm left with the number of neutrons, so 12 neutrons. And last but not least, how many electrons does the atom have? Well, we said that there are 11 protons, right? And we know that protons are positive. If we assume that it's neutral, then we need 11 electrons to balance out those 11 positives found in the protons, because electrons are negative. Okay, now just as an aside, let's say that we wanted our atom to have a charge of +1. Well, we have 11 positives in the nucleus. To cancel all of them out but one, in other words, leave a single positive charge on the atom, we would need 10 electrons. And if, say, we wanted it to have a charge of -1, Well, we would need to cancel out all the positives of the protons and give it an extra electron to give it that extra -1 charge. So that would be 12 electrons. Sorry for my crazy handwriting. For whatever reason, my board doesn't like me. Okay, these guys here are special scenarios where we don't have a neutral atom. In fact, these would be atoms that have more or less electrons than their number of protons, and we call these ions. We're introducing them now. We'll see them later, at least a lot. We'll see them a lot in the future when we get to Unit 4. Okay, make sure you answer the online questions, and we'll see you tomorrow.